Okay, so today what we're going to talk about is measures of central tendency. Now you guys have learned measures of central tendency before. We're just putting it into a more statistical reference. So measures of central tendency are mean, median, and mode. Those are measures of central tendency. Now, the arithmetic mean, otherwise known as just average, okay, is commonly used in everyday life. You guys know this. Now, over here to the left, you have these equations. I am not saying you have to memorize these equations, which is fine because you already do have them memorized, but you do need to know how to read them. That's really important because if you look over here, on your test, you get access to what's called a formula and table sheet, okay? It's going to be a PDF, but I need you to understand this is how big it is. Yeah, not kidding. Now, it breaks it up between chapters, like so you know which goes to chapter or whatever, but it gives you all the formulas. Your responsibility is to know when to use the formulas and how to read them. And that's really, really important. You have to know how to read them. So that's what we're going to practice today. So this right here is one of the formulas that you'll be given. And you have to know what each of these symbols mean. Now the first symbol we're going to talk about is this guy right here. That's what's called a sigma. Okay? So if you're planning on joining fraternity life when you guys get to college, you'll see that a lot. It's called a sigma. Okay? And it means sum. So over here we have this little box. It says, what do these symbols mean? In parentheses, I'm going to put how we say it. That's called sigma. Okay? And it means the sum. Sigma means sum. Okay? Now, you're taking the sum of whatever comes after it. So it's saying the sum of x sub I. Now, when you see x sub I, it literally is depending on how many terms you have. That's just the number of terms you have. So like x sub I, you could put a 1 in for an I, or a 2 in for an I, or a 3 in for an I. So that would be like the sum of your first term, second term, third term, fourth term, fifth term, whatever. So if you had 10 terms, it would be the sum of your first term, second term, third term, all the way to your 10th term. Does that make sense? So x sub I is just your terms, divided by this lowercase n. Now this lowercase n changes depending on what you're dealing with. That typically just means the size that you have, but it depends. Because if you'll remember, we have two different things we're talking about, population and sample, right? If you guys remember, a parameter was a descriptor of a population, and a statistic was a descriptor of a sample. So there are different formulas for population or sample. Now, these are those two formulas. The first one is population, and the second one is sample. First one is population, the second one is sample. Now, if you'll actually compare those two formulas, they look just about the same, and they really are. Like to find the arithmetic mean, to find the average, it's the same regardless of whether you have a population or a sample. The formulas just look different. So let's start with the population. The first symbol you see kind of looks like a lowercase u with a like tail over here. That's what we call mu, M-U. We say that as mu. And what that really stands for is the population mean. So whenever you see mu, that is just the population mean. Now, the population mean is equal to 1 divided by capital N times the quantity of, it says x plus 1 plus x plus 2 plus all the way to x sub n. So if you look at this, it's literally just the sum of all your terms, just like we saw up here, right? The sum of all your terms, and you're multiplying by 1 over capital N. Now the capital N is only with the population. The capital N is going to be the size of the population. Or some people say the number of terms in the population. It's just however many numbers that you have, right? The size of the population. So this is literally just average. You add them all together, you divide by how many there are, just like normal. That's just how we write the formula. Now the next one is the sample mean. Now this one looks like this. It has an x with a bar on top of it. Here's how we say it. We literally just say x bar. Now you'll notice sometimes on Hawks Learning or on our practices or in real life, you'll see the literal x with the bar on top of it, and sometimes they'll literally just write out x bar because their program can't write it. So whether you see it like written out or whether you see it with a symbol, they both mean sample mean. They both mean sample mean. Now again, with the sample mean, we're adding up all our terms, x1, x2, all the way to xn. And here, we divide it or multiply it by 1 over lowercase n. Just like capital N was the size of the population, lowercase is the size of the sample. Now, you're going to notice this semester that we're going to start seeing a lot of different symbols. You have to know what the symbols mean. So that's why I gave you this box. When I took this class the first time in my life and then I took the next level and the next level, I seriously was so confused by all of these different symbols because they were just given to us and they were told, just learn them. You just have to know them. So I'm trying to create a system to help you remember them, a place that you can go back and look and say, oh, this means this. So this little box is a really important box. You guys are going to have to know that in the future. So make sure you, highlight it, bring attention to it, make it easy to access in the future. So let's just do some examples here. The first thing we're going to talk about is sample mean. It says, example, calculate the sample mean of the following sample data values. So they literally just gave me a sample of data values. We don't know how many there originally were. It's just a bunch, and we just have to find the mean or the average. Now, since this is a sample, would that be mu or would that be x bar? That would be x bar. Now, to find the sample mean, we need to take the sum of all of my numbers and divide by how many there are. So we're going to have to get out our calculators. And let's add them together. 27 plus 30 plus 44 plus 12 plus 22 plus 28 plus 19. What do we get? 182. Then we have to divide that by how many terms we have in the sample. So we have 1, 2, 3, 4, 5, 6, 7 terms in the sample. So we're going to divide it by 7. And what do we get? 26. Now what's awesome is this is a really nice number. You guys know as well as I do, sometimes the average isn't always a nice number, but somehow we got lucky, and it's a nice number. Now, on Excel, which is going to be really helpful for your homework, because on your homework you're going to have to find the average a lot, you don't want to sit there with your calculator and say this plus this plus this plus this plus this divided by this. On Excel, you don't have to do that. You're just going to use this little function right here, and you're going to type in equals average, and then you're going to put in the cell range. So here, I have an example for us. I put those 7 numbers right there. And to find the average, I'm just going to come over here and I'm going to say equals average, open your parenthesis, and you're just going to highlight your cell range. You want the average of those 7 numbers, close your parenthesis, and it'll give you the same answer, 26. We all okay with that? Okay. Now the next thing we're going to talk about is deviation. And it says the deviation of a value is based off of how far a given value is from its data point. Go back to the previous example and find the deviation from each data point to the mean. Deviation is another way of saying how far, what's the distance from this point to the mean? How far off are they? So, to find the deviation, I'm just going to come over here. And you know that my mean is 26. I want to see how far away from my mean is each one of these points. So I would take my top one, 27, minus 26, and what would I get? 1. Then I would go 30 minus 26, and that would be 4. We go 44 minus 26, and that would give me 18. And we're just going to do that for each one of these points. Now when you're done, you're going to have a bunch of different numbers. It's important that you understand how to read these numbers and what they mean. If you have a positive 1, that means that that data value is only 1 more than my mean. 4 means it's 4 more than my mean. 18 means it's 18 more than my mean. Negative 14 means it's below. It's 14 units below my mean. So it kind of shows you how close or how far away each one of our data values is from our average. Is that okay? It kind of shows you the deviation of our sample. Now, on Excel, it's a lot easier to do because all you have to do is get like a formula in there. Now, we know that my mean is this 26 right here. I want to take each one of these values and subtract, so I would just go equals, and then I'm going to click on this cell, and I'm going to subtract my mean. But when I go to fill in for the rest of my numbers, I want that mean to stay, so I'm going to put an absolute cell reference on that cell, which is D1, so I put the dollar signs there. And then I can go through and I can drag it all the way down. Now, what deviation is used for is to help us find like outliers. We're going to talk about the actual formula to find outliers in the future, but outliers are the numbers that just don't really fit in with the data. They're too big or too small to fit in the data. So you can see like right here and right here, 18 and negative 14, they're the furthest points away from my average, so they're the ones that are most likely to be the outliers, and we'll talk about that more in the future. You guys okay with that? Awesome. I asked that a lot, don't I? Okay. Now, sometimes the mean is not an ideal measure to represent the data. Observe the following situation. Mrs. Getz has 25 students in her staff class. After giving the Unit 1 exam, the resulting grades are listed below. Now, just as a piece of information, which you guys should know, NHI stands for not handed in. Now, when someone puts an NHI in your grade book, it really means a 0, and it'll drop your grade like you have a 0. But when you complete that exam, I'll go back in and I'll put in the actual grade, yes? So NHI really just stands for 0. Would it make sense for me to find the average of my test scores at this point in time? Why not? Yeah, all of these NHIs, we have 1, 2, 3, 4, 5, 6. All of these NHIs would drastically drop that grade. It would drastically impact the average score. It's not an accurate reading, right? So I'm going to put no. The 6 NHIs would drastically impact the average score. So those NHIs, those zeros, would really stand for an outlier. They're really going to impact my average score. The average at this point in time would not be a good reading. Now there's actually a word for that. Okay, so it says those NHIs are going to drag Mrs. Getz's test average down since they're so much lower than the average student's grades who took the test. They would be considered outliers, and we talked about that earlier. Now, the phrase that we are looking for is this means that the arithmetic mean is not a resistant measure. Okay? A resistant measure is a statistical measure, so a measure of central tendency, mean, median, range, mean, median, mode, that's not affected by outliers. Okay? That's what a resistant measure is. And since these outliers do affect the mean, they do impact the number that we would get back for the mean, it is not a resistant measure. Does that make sense? Okay, let's go to the next page. Now the next thing we're going to talk about is a weighted mean. You guys know what a weighted mean is, you just might not have calculated it. A weighted mean is similar to an arithmetic mean, except it allows you to give different weights to each data value. A really good example of this would be your grade. You know that in here, 50% of your grade is tests, 25% is homework, and 25% is your final. That's a weighted average. That's a weighted mean. So here's how we calculate it. In college algebra, the final grade is weighted as follows. 20% is homework, 10% is quizzes, 50% is chapter test, and 20% is the final exam. If a student has an average of 92 on their homework, 85 on their quizzes, 78 on their chapter test, and they got an 84 on the final exam, what is their weighted average for the course? What grade are they going to get for their course? Now to figure this out, you just have to take their weights and multiply it by their grades and add them together. So if they get 20% of homework and they got a 92% on homework, that means it's going to be 20%, which is 0.2, times their grade on homework, which is 92. Then we're going to add that to what they got on the quizzes. So 10% of their grade is quizzes, so that's going to be 0.1, times the 85% that they got on their quizzes, plus their chapter test. So we know 50% of their grade comes from their chapter test, and they average a 78% on their chapter test. And then finally, 20% of their grade is their final exam, and whoever this student is got an 84 on their final exam. Now, something that you should be aware of before you just start putting this into your calculator, all of these percentages should add up to what? 100%. So 20%, 10%, 5, or 50%, and 20%, those all need to add up to be 100%. Otherwise, your weight's not going to work. Other than that, let's just put this all into our calculator. So 0.2 times 92 plus 0.1 times 85 plus 0.5 times 78 plus 0.2 times 84. And what do we get? 82.7. That means they got an 82.7 in their class. That's their absolute grade, which means they got a B. They got a B. So that's how weighted means or weighted averages are calculated. Take the weight, you multiply it by the average of each section. Okay. Next one we're going to talk about is the median. Now you guys have done the median before. Median is just another word for middle. The median is the measure of center, that is the middle value of the data when it's arranged in ascending order. It has to be in order to find the median. Now, two sets of data that I have here. One has an odd number of data. Odd number of data is really easy to find the median. It's just the one in the middle, right? It's just the one in the middle. But when there's an even number of data, you know that the median is going to be in the middle of the two middle terms. So how do I find the median when there's an even number? Add them together and divide by 2. So I would take 8 plus 9 divided by 2, and that gives me a median of 8.5. Okay? Now, finding the median by hand is a pain in my butt because it takes forever to put those numbers in ascending order, then figure out how many numbers there are. Is it odd or even? What are my two middle terms? What is my one middle term? And go from there. On Excel, it's much, much easier. You don't even have to put it in order on Excel. You just type it in. So if we would go back to this Excel doc that I have here, I have those two columns. All you have to do is type in equals median, and then you select your data, and it's going to spit it out right off the bat. You don't have to even have it in order. Same thing over here. You just type in equals median, select your data, and even if it's even, it'll do the calculations for you, and it gives you back the right number. Sound good? Okay, that's going to be incredibly helpful on your homework. So you don't have to put it in ascending order. You copy that data, you put it on the table, and you just find it. Easy, easy peasy. Now the next thing we're going to talk about is the mode. The mode is the most frequently occurring value and is the only measure of central tendency that can be used on non-numerical sets. So here's what I mean by that. The mean, the average, you can only use on numbers. You can't take the average of like hair color, right? The median, you have to use with numbers. You can't have the median. You can't find the middle of all of the types of sweaters you guys are wearing. That doesn't work. But the mode, you can. I want you to think of it this way. Let's say I'm ordering T-shirts for Hey Thai Stuco, right? And I want to know which T-shirt do I need to buy more of. I would look at which size, small, medium, large, extra large, got the most orders, the mode, and that would tell me which one I need to order more of. Does that make sense? The mode is the only one that works with non-numerical data sets. Now, there are 4 different types of modes. The first one is unimodal. Unimodal, like a unicycle, just means that there is one mode. So if you look here, 0, 0, 0, 1, 2, 3, 4, the number that occurs the most often is 0. So in unimodal, there would only be one mode. Bimodal, just like a bicycle, means that there would be two modes. Bi means two. So 0, 0, 1, 2, 3, 3, 4. We have 2 zeros and 2 3s. That means we have two modes, 0 and 3. No big deal. Multimodal means that there's more than two. That means there could be 3, there could be 4, there could be 5, whatever. Multimodal means more than two. So here I have 2 zeros, 2 1s, and 2 3s, but only 1 2. That means we would have 3 modes here. Now I need you to understand with multimodal, if you would have like 0 0, 1 1, 2 2, 3 3, notice how there is not more numbers than something else. So here this would be no modal. There would be no modes in this in this data selection because each number has the same amount as the others. Here it's multimodal because there's only 1 2. Does that make sense? And then finally is no mode. That's when there's the same number of all the numbers. Now on Excel, this is a little bit different. On Excel, when you type in mode, you're going to get a couple of different options. So the first option that you see is mode.mult or mode.single. Be very careful here because if you type in mode.single, so mode.sngl, and then select your data value, it's going to work for that first set because it's going to give back only one mode, hence the mode single. But if I do this for the second data set, we know there should be 2 modes, and it's still only giving me back that first mode that I find. So that's where this second mode comes in handy. It equals mode.NULT, and it returns a vertical array of the most frequently occurred. So if there's more than one mode, it will spit it out. So if I use the mode.mult, notice what happens. It'll pop out 2 numbers. You okay with that? It'll pop out 2 numbers. So if I come over here to the multi-mode, it's going to pop out 3 numbers. Now, the mode.mult still works if there's only one mode. Notice if I come over here and you got equals mode.mult, and I select this data, and there's only one mode, it doesn't make a difference. So it's really important that we only use the mode.mult because if there's multiple, it's going to find it, and if there's not multiple, it doesn't make a difference. Now I want you to notice what happens if there is no mode. So mode.mult here, if you select the data and there is no mode, it's going to come back not applicable. So that'll tell you that there is no mode, there's nothing we can do here. All good? All right. Now the next thing we're going to talk about is the relationship between the mean, median, and mode. Now yes?
I was going to ask if you wanted us to leave it like that, or would you rather us put no mode?
On Hawks, it'll say no mode. It'll say no mode. That's a great question because it's multiple choice. Good one. Okay, now the mean, median, and mode do have relationships with each other, and the visual representation comes back a little bit different. So the first thing we're going to talk about is a bell-shaped distribution. When your mean, median, and mode are all the exact same, let's say I give you a data value set, you put it into Excel, you find the median, you find the mean, and you find the mode, and they're all the same, it's going to look like a bell-shaped curve. Why do we call it a bell-shaped curve? Because look, it looks like a bell. Are we all on the same page there? That's all okay? Now the next type that we're going to talk about is called a positively skewed curve. And this is what happens when the mode is smaller than the median and smaller than the mode, okay? Or than the mean, sorry. The mode is the smallest, the mean is the biggest, okay? Another word to describe this right here is called right-tailed. Now, if you'll look, this graph is like heavy on the left side and it's really light on the right side. It looks like it has a tail coming off to the right, which is why it's called right-tailed, okay? Now, the next one is a negatively skewed curve, and the reason they call it negative is because this is like a number line. If this was a number line, this would be positive, this would be negative. It is skewed in the negative direction. We have a left tail here, left-tailed. And that is when the mean is smaller than the median, which is smaller than the mode. The mode is the biggest, the mean is the smallest. So the big thing here is you need to be able to tell the difference between these two graphs, not only with names, so bell-shaped, right-tailed, and left-tailed, but also with where the mean, median, and mode are located. If it's bell-shaped distribution, they're all the same. They're all in the same line, they're all in the middle. The difference between right-tailed and left-tailed is literally only the mean and the mode. I want you to look at the median there. Look at the median in those two. Notice how the median here is in the middle and the median here is in the middle. Okay? That's still never going to change. The big difference is the mode in the mean. And the easiest way to figure out which one of these lines should be the mode and which one should be the mean is to think about the actual meaning of the word mode. Mode is finding the number which occurs most often, right? And in a graph, whatever occurs most often is going to have the highest bar, correct? So this is the highest point on my graph, so the line that touches it is going to be the mode, okay? So this highest point is the mode, which means on right-tailed, the mode is all the way on the left, and on left-tailed, the mode is all the way on the right. Now finally, we need to talk about how to know which one of these measures of central tendency to use. They're going to give you problems and they're going to say, here's the mean, here's the median, here's the mode. Which one of these descriptors is the best descriptor for this problem? Which one should I use? Now you should use the mean when you are dealing with quantitative data, meaning when you are dealing with numbers, and when you are dealing with numbers without outliers. So when I was talking about that example with all the test scores and we had the NHIs, we had a lot of outliers in that data set. It was not a good descriptor. The mean was not a good value to represent that data, okay? Now, the distribution of this would almost be symmetrical. The mean and median would be very close. So if you're given a data value set and the mean and the median are very, very close, the mean is an okay value to use. Now the median still needs to be quantitative data, so still numbers, but if you have outliers, you should look at the median to represent that data. Okay? Now, this would be ordinal. This would be ordinal, which means that there would be order to these numbers, right? Nominal data is not okay with the median. Nominal data is not okay. And then finally, mode, which is nominal data, is qualitative. You can use mode for nominal data, which is qualitative. So like sizes of t-shirts, something like that. Are we all okay? All right, that's all we got.